Hello, everyone. In this lesson, I'm going to be introducing how to use our standard normal or Z table. So before we begin, let's first talk about what the Z table actually lets us find. So when we're calculating probabilities for a standard normal probability distribution, you may want to recall that to find the actual probability between 2 points A and B, we would have to take the integral from A to B on our function, which represents our distribution, in this case, normal distribution, across the x-axis. Now, we're not going to be doing that in this class. What we're going to be focusing on is finding our probabilities using our standard normal table. So the way we do this is we start with a normal distribution, which is centered on mu, and we have some x value, right? So we have a normal distribution centered on mu with a standard deviation of sigma. And then we are going to transform this to our Z distribution using the transformation Z equals x minus mu over sigma, which is really just telling us what is the distance from our actual data point to the middle of our normal distribution. And then scaling it by how spread out is our normal distribution by our standard deviation. And this puts it into the standard normal, which is a normal distribution which is centered at 0 and has a standard deviation of 1. So once we've scaled any normal distribution we have, this normal distribution is our distribution in the actual data space. This is our x distribution, and we're transforming it into our standard normal, in which case we use the letter Z. Now for our table specifically, we have to have a positive value. So this would be some value, let's say it's A, it has to be positive, which means it has to be to the right of 0, meaning that we can only get values which are on this side of our normal distribution. And specifically, we're looking for values or probabilities to the left, meaning we're looking for probabilities of some value A looking to the left. Now, I bring this up because we've talked about in the prior lesson, how do we actually transform to get it into this form? But once you have it in this form, we need to now talk about how do you look it up in the table. So if you kind of look at the fact that all of our values have to be positive, that means the lowest value on our table is going to be 0. And we're going to have values from 0, and they're going to go up to about 3.49. And at that point, once it goes beyond that, we would just have to use the fact that if we're looking to the left, it would count for pretty much all the data. We'd say it's probability of 1. If it's looking to the right, we would say it counts for basically none of the data, so it's 0. So first things first, we have to get it into this form. Once you have it in this form, then you would go to your table. Maybe you have something like this. What is the probability that Z is less than or equal to 1.49? So you go over to your table, and this is what our standard normal table looks like. And you see we have this little graphic up at the top left to kind of show you that you need Z values that are above 0, meaning that they're above the center point, and it's shading in the values to the left, meaning it's the probability to the left of that positive value. Now, along the left side of your table, this is going to be your units and your tenths place. So we got 0.0, 0.1, 0.2, all the way up to 3.4. Along the top of your table, these are going to be your tenths or hundredths place. So for example, I said, what is the probability that Z is less than 1.49? So you would go down to 1.4, and then you're going to go over to 0.09. You're going to see where those intersect, and this is going to be your probability. Let's do another example. Let's say that we had, what is the probability that Z is less than 3.00? You would go along your left side to get to 3.0. You would look at your first column, the 0, 0, and we would get a probability of 0.9987. If we had the probability that Z is less than 0.44, in this case, it would be 0.4. You go over to 0.04, you see where they intersect, and you get a probability of 0.6700. So you can see that pretty much we have any value starting from 0.00 up to 3.49, right? So we did 3.4 0.09, we get 3.49. The lowest value we have is from 0.00. And notice that for 0.00, we have a probability of 0.5. This is because at that point, we know that we're at the middle of our standard normal, which means the probability to the left of that should be half the data because we have a symmetric bell-shaped graph, meaning that your probability to the left of 0 is 0.50. So all of your probabilities will have to be something between 0.5 and 1. And this is why it's so important to understand our transformations, because if we have probabilities that are looking to the right or to the left and they're less than, so that means they're negative, this means that you have to use things like the complement or symmetry to get it in a form that we can use, which is to say using a positive value to the left. And the way you would do something like this is you would take the entire distribution, which is equal to 1. You would subtract off everything to the left of that value, and you'll be left with just what's on the right of that value. And that's really it. There's really not a lot to use in this table. You just need to remember that on the left side, right here, you've got your ones and your tenths place. On the top, you have your hundredths place, and then you just need to find the intersection of where your value is. So again, 1.49, you go to 1.4, you go to 0.09, you get 0.9319. The last thing is I talked about the fact that this starts at a probability of 0.5000 because it starts at 0. Our table does end at 3.49. And this is why I said if you were beyond that, your probability will just have to be either equal to 1 or it's equal to 0. Now, there are probabilities beyond this, but there are limitations to this tool. A few of them being, 1, it does not go beyond 3.49, whereas probabilities can go beyond 3.49. The second thing is, all of our z values based on this left side here and the top part are going to be based on 2 decimal answers, meaning you're rounding, because you can have probabilities, or z values in this case, that are beyond 3 decimals, 4 decimals, 5 decimals. Last thing is in our table, you'll notice that all of our probabilities are in terms of 4 decimals. Again, this is rounding. So this table is giving us approximate probabilities to go in place of our precise probabilities that we would calculate if we were using integration. And that's it. That's how you use the standard normal table. And from there, you should be able to do all the problems that we cover in this class.
Thank you for watching. To continue learning, click the linked video here for the next lesson. If there's a topic you'd like me to cover, let me know in the comments. Don't forget to subscribe, and I'll see you in the next video.